Welcome to Happy Path Programming. I'm Bruce Eckel.
I'm James Ward. All right, welcome to Happy Path Programming. We have some exciting news.
Yes, we do.
We finished our effect-oriented programming book, and so we have our co-author, Bill Frazier, with us. Welcome, Bill.
Hello, everybody.
I will argue Bill is the lead author because he's the one that dragged us through the whole process. I probably would have given up beforehand.
That's a good point.
It wasn't for...
He led the way, and you and I were in a supporting role.
We were, and plus, Bill used to work for Zyverge, so...
The company behind Zio, the technology that we used in the book.
Deep in the middle of it.
Yeah. So this is kind of like a celebration episode of
it's absolutely
getting to completion.
We are all feeling relief.
Yeah.
It's actually done, but not just relief that it's done, relief that when we pick up the book, we feel pretty good about it.
Yes.
Yeah. I've actually now read it many times, and it's pretty good.
It is.
It's good and quick to read.
Yeah.
It is. Yeah.
You don't have to dedicate, a month or two of your life. You can get through it in a sufficiently determined day if you want.
On your phone.
On your phone. We put a lot of work into making it phone friendly, and so you can just sit on a bus and scroll through, and
you don't have to go through phone gymnastics to look at the examples because we kept them narrow, kept them small.
Yeah, we oriented it for portrait mode, right? So you can read it all in portrait mode.
Yeah.
Yeah, and one of our tests is just looking at the line length of the output, and if it was above 47 characters, it fails the build.
Yeah,
that's right. Yeah.
Got to keep it nice and skinny.
And we peaked at about 300 pages, and then we started pruning it back, and it's like, if this doesn't move the story forward, it goes out.
Yeah, there's a lot of interesting, reasonably high-quality material that just didn't belong there. So we have cut out everything that doesn't fit that pretty narrow focus.
But I feel like it was also useful in the evolution because we saw it and our understanding was deeper, and then we realized, no, this isn't going to help people.
Yeah. 4 years in the making.
Yep.
It's been a journey. So, and a lot of that 4 years, which we'll talk about the kind of journey later, but a lot of it was just figuring out what was needed in this space. We didn't want to just create a book about Scala Zio,
or functional programming.
Yeah. We really wanted to, and it took a while to get there, but where we got to is we really wanted to help people understand what effects were and how they can help them.
Yeah, I was the test case because I kept not understanding. I kept trying to read functional programming books and getting lost. I kept not understanding what we were doing. And finally, I realized I don't know what the point of this is. And so we started to kind of say, what is the goal of all this? And eventually we came to realize that it was the goal ever since we dragged ourselves out of the mire of assembly language programming, which is taking little pieces and putting them together and making big pieces.
And I think you not understanding some of the stuff that James and I had already struggled through in years prior was really valuable because we could spend extra time getting practice explaining it to you and either get better at explaining a topic or realize this is not necessary. Like, we don't have to explain this concept here, so let's just sidestep it and leave that to someone else to discuss in a different book.
Right. Which has already been done. There's lots of books on functional programming. I tried to read them. I got lost, and I think lots of other people got lost, mostly because it was, this is a cool feature, this is a cool feature, this is a cool feature. It's like, well, why? I mean, some of it is like, that's pretty interesting and neat, but I didn't get the big picture until we started to kind of focus and ask that question, and realize, oh, this is what we're doing.
And some things aren't even presented as a cool programming feature. They're presented as a cool bit of math. And it's kind of left up to you to make the jump to, okay, this interesting bit of math here, how do I actually bring that into my program? Like, how is it going to help me out in my day-to-day career?
Like, interesting, but why? And we kept coming back to, as we were formulating what we eventually got to as being the book, is we would look at things and be like, does this help illuminate what effects are and why they're useful? And if not, we mostly tossed it. It's like,
that was
not helpful.
One of the important parts of finally landing on this title, because so much stuff kind of came in and out of the book, when it was in an earlier form. And once we struck on this title, that was kind of our guiding light of, okay, is this appropriate for teaching effect-oriented programming? And, just depending on the answer to that question, are we going to keep it in?
So we've talked about effects, I think, a few times on the podcast, but since we've finished the book on it, maybe it would be helpful to just give a little bit of what effects are and how we talk about them in the book.
And
a little teaser to the book.
Why effects?
Why effects?
Why effects, I think, is really important, because it's like, oh, yeah, it's interesting. Effects. So the way that we sort of capture effects is the idea that, well, you have your perfect functions that do everything in kind of the platonic ideal of a function is you pass it some arguments and it gives you a result. Cool. But, and that's kind of how we teach it. But we sort of sidestep the idea that, well, there are functions, like if you have a computer full of perfect functions that never interacts with the outside world, then all it does is heat the room up.
Yeah.
It's not, you got to at least produce a result, or you got to, maybe check the temperature or look at the time or something. And those are all basically, you don't know what the temperature's going to be. You don't even know if the temperature sensor is working. There's all these messy things that happen when you try and you leave the world of perfect math and you talk to the outside world. But that's what makes the programs useful. And I think what we've done in the past is we've said, oh yeah, those things happen and you don't always know what's going to happen. And it's the job of the programmer to write the code to compensate for all the uncertainties of that. And people haven't really looked at it and said, well, why don't we look at those uncertainties and those unpredictabilities and kind of let's step back and treat those as their own thing, and maybe there's something we can do about it, rather than just saying, well, you never know, the network might go down, who knows, can't do anything about it. And instead say, well, maybe there is something we can do about it. Maybe we can put little boxes around it. Maybe we can add that information to the type of the function and do something with it so that at least we're better prepared, or we cover all the error conditions, or we expect, or we're able to test things. For example, there's an example that you inserted towards the end of the process where you said, well, what if it's 11:59, you start a process and then that process checks and it goes, oh, it's the next day. Well, the previous days. Well, how do you test for that? Because are you going to sit there and wait? And so if we can control those,
like you can't wait until have a test that just exactly right.
Exactly.
Like, sorry, your test could take 24 hours to run.
Yeah, because you didn't start it at the right time. So it's like, well, it's kind of obvious. Isn't there some way we could make it the time that we want to test for?
Yeah, you don't want to incidentally discover that your code misbehaves at a certain moment in time.
Because it's inconvenient to test it.
Yeah, you want to dictate, hey, let's just make we are going to force this thing to run at all those inconvenient boundary times. And we're going to do it at 11:59:59 on the last day of the year. And, if we want it to span over into the next day, we explicitly say that in the test. We say, okay, now insert a delay, and then you just have complete control over that timing in your test, rather than I've worked at companies and organizations where it's just kind of understood, if you run these after 5 p.m., it's probably not going to work. And we don't really know at heart, what is causing that. But these were developed by someone during the workday, and they unintentionally made them time dependent.
And we don't even know how to test for it. And one of the huge things is the testability of stuff that is unpredictable. And so if we can control those things and inject the kinds of situations that we want to test for, then we can test for that all the time. And of course, obviously we want to catch things as early as possible, and we do that. Some of that using strong static checking and other mechanisms. But then ultimately, you've got to be able to test things under all the worst situations, and you've got to be able to reproduce those. And we haven't really been able to do that consistently in the past, and this allows you to do that.
So the book is called Effect-Oriented Programming, and what's the subhead on it? What do we say? A paradigm for... We should have a copy of the book right here to
we do
reference it, so we make sure we get it right. But
there we go.
A paradigm for creating reliable, adaptable, testable systems.
Yep.
Yeah, and so really the book is focused on exploring this concept of how effects can help you do that. And we go through a bunch of the kind of whys, why are we doing this? And then we go through the mechanics of what's needed to get to those reliable, testable, and adaptable. Yeah, composability. So we kind of expand on how that's actually done. In this book, it was Scala Zio, because that's something that Bill and I are familiar with. But there are other effect systems, other ways to do effects, and so so maybe in the future we'll have other versions of the book that explore the same concepts but using other technologies.
The point being that it's not limited to this particular combination of things. In fact, a lot of work was done with effect systems using other approaches, which were, one could almost argue, eventually evolved into this through a series of experiments. I mean, some of them are being actively used. Katz effects, and I can't remember, there was something,
Scala Z.
Scala Z. Yeah, that was one of the original ones. And I remember watching some videos about that and having no clue.
Yeah.
Zero clue. It was...
Yeah, so there are those earlier attempts within Scala, and then there are also other languages which take it further than Scala with Zio, where all of these things are baked into the language itself. You do need some discipline when writing effects in Scala, using a library as opposed to...
It's not enforced by the language.
Yeah, it doesn't back.
Yes.
But even the Scala language is looking at adding some type of effects to the language itself. We'll see where that goes. But I think what's important here is that we did use Scala Zio, but the book is not about Scala Zio. Scala Zio is just the way that we teach the concepts. And so that's one reason why the book will hopefully be pretty portable to other technology sets, is that it's not about Scala Zio.
And one of the things that I really like is I'm sort of presenting this as, you kept seeing how I wasn't getting this, and you said, well, how can we let's see if we can throw away or hide a whole bunch of stuff so that we just get down to the essence of the examples. And then that's when it started just becoming a lot clearer to me, and then I could more clearly write about it. Because it's really the essence, and the examples have been reduced to they're like I don't know if it'd be possible to make them any smaller than that. They're often
Simplest thing that could possibly work.
3 or 4 lines. And so it really zooms in. You don't get distracted. We also used an extreme subset of Scala. We didn't, you don't see type annotations. You don't see, so it's really clear, and it's really hard to get distracted by the extra stuff because that's hidden. Yeah. And it's all tested. It's all there. The code is there. When you download the code from the repository, you can run everything. But the part that we show in the book is just the...
It's almost like the whiteboard code that you would write.
Yes, it is.
It's like,
exactly
it doesn't matter that it's Zio.
Right.
It's like, yeah, we have to use some Zio APIs to show the concepts, but it really is supposed to be there's some word for that. Like, the code that you write on the whiteboard that is really just agnostic to some implementation. But it is all runnable, of course.
And that was another guiding principle is, okay, we want to show this bit of the Zio API that facilitates this example. Oh, well, while we are explaining this API feature, let's do this other one as well. And then having to remind ourselves, like, no, that's for the Zio docs. That is if you are really focused on explaining Zio. That is not our goal. We appreciate the Zio docs for what they are, and you should absolutely jump over to them, consult them as needed. Our book does not replace those. That is not its goal.
No. And the one step at a time approach, there's like one concept per example, and then showing how they can build on each other. That I found just super helpful because I could look at this and go, oh yeah, you're doing this one thing. Oh, and that's one of the kind of amazing things about an effects library is the ability to build pieces together, to actually compose things together seamlessly.
Yeah.
I mean, pretty much. You can just say, oh, I want this too. You just tack it on.
Yeah, and you look at systems outside of FX, and they really generally don't compose very easily or well when you bring in resource management, air handling, dependencies. I don't know what other things.
All those things that the programmer is just supposed to deal with when they put their program together.
Exactly, and so that was something we really wanted to highlight. It was like, oh, you actually can fit these pieces together and maintain all the things that are real world, the effectful, side affecting parts of an application.
The flexibility.
They still fit together even when they're side affecting.
Yeah. So basically you can just tack this functionality on. And I know, Bill, you've talked about some experiences that you've had where you could and couldn't use the effect system, and you said, okay, so we spent 2 weeks doing this thing that would have taken me half an hour, and that's a pretty damning story.
Yeah, if you just want to time out some code and have it canceled in a reliable way with effects, you almost don't even think about it. You just say,
oh yeah, add this,
time this thing out.
Yeah.
And you know that everything underneath is going to be interrupted, cleaned up. And it just lets you focus on such a tiny fraction.
The one thing code you want to do, rather than all of the impacts of that in a normal piece of code. And imagine the 2 weeks, what does that cost a company? Not just the programmer's time, but all of the lost opportunity, all of the slowdown and everything. It's
but you see this like all the time. At least I don't see bugs everywhere in code. Not my code. My code's perfect because I use effects. But but like the Spotify app, I go in, I launch the thing, and then it just sits there and spins and spins and spins, and I'm like, really? Was it so hard to add a timeout to this thing? And it's like, actually, it probably was.
Oh, yeah.
That's probably why
it was so much work. They said, "Oh, I don't want to do this." My Sonos speakers have become bricks, since whatever happened there. I don't know. And it's like, yeah, well, the failure rate of software projects is so embarrassingly bad. So this book that I read recently called How Big Things Get Done, they've got all this data about projects that they collected, and so they have this database. And so the least successful projects that come in late and over budget and maybe don't even work right are storing nuclear waste. The second worst is building nuclear reactors. The third worst is IT projects. So we're, basically at the bottom.
We're in good company.
Yeah, we're.
And we're not dealing with nuclear waste or nuclear reactors. We're dealing with software, which is supposed to be fungible, easy. It's just bits and code.
Mm-hmm.
It should be easier.
Mm-hmm.
Yeah.
Yeah.
So I think part of the motivation for working on this book is that we believe that there's a better way to build software that can be more reliable, more adaptable, more testable, all those things that are in our subtitle there. And we think that the world needs this. And there are technology areas where you can get it today in Scala and in Unison and Rock and OCaml. But I think this is such an important concept that most languages will eventually have either library support or language support for this. And so why not start learning the concepts today?
It's a fundamental shift. It's like, it could even be considered on the level of when Dijkstra wrote Go To Considered Harmful, which is ultimately what moved us into, pieces of code should all be in functions. That's what got us there. And because before that, we had subroutines, we had jumping around and stuff like that. And he showed that, you need to have a wrapper around this thing that is reliable and that was a piece of composition. And there's, namespaces was another piece that allowed us to do this. And I feel like, this could well be paying attention to these kinds of things, which we basically swept under the rug and said, that's just part of the deal, something you have to deal with. And I think this is that kind of a shift. Somehow we have to start paying attention to those things and treating them as first-class members of programming rather than just something every programmer has to deal with. Because your example of, I could do this in 5 minutes or whatever, versus 2 weeks and still not even know if you've covered all the bases.
Mm-hmm. Yeah. And even when I'm working in a non-Zio, non-effectful project framework,
it changes the way you work.
I still will categorize things into the simple pure functions or the ones that I have to worry about and take a lot of extra care around. So even if I don't have the really streamlined effect system experience, that grouping is still helpful because I can draw the circle around this thing and say, this is the dangerous code. This is where all the care and attention needs to go into. And the pure simple functions over here, just write a unit test or two, move on with your day.
Yeah, it's a conceptual tool. And for me, this process, finally, I've been struggling with what the heck are errors and failures and things like that, and slowly adding pieces and understanding and trying to, why don't exceptions work? And all this. And this has kind of brought a close to that when you look at errors as values rather than exceptions. Definitely moved us forward from where we were before, but then we ran into this other wall, which is, how do you make sure that you've covered all of the problems? And without having it incorporated into the type system, you can't.
Yeah, exceptions are, like you said, they're a good step forward, but they are still treated as this special, separate thing that just blows out the side of your function, rather than your function just saying, here is the error value that we got when we
And
execute
here are
this code.
all the possible error values that you need to cover.
And it really prevents good reliability and good composability. And so that's part of what we talk about in the book is, this is how you can do error handling in a way that helps you actually increase reliability and increase your composability or adaptability.
Yeah, and I would say that's not even, that's incorporated into effect system, but that predate, that's
For sure.
I would say a functional error handling approach. Is that what you call returning values as error?
I don't know if there is a
value.
general, errors as values. No.
But
And I know one of the things that is served by Scala 3 as our choice of language here is union types, which I don't even like really saying that out loud because it's a kind of gatekeeping term, but it allows you to express or in the type system.
Mm-hmm.
So instead of everything being reduced to some common supertype of all of your errors, you just say this function can fail with a user validation error or a network error or a
divide by zero
error. And so just as you build a more complex function and you add more fallible operations, the compiler just tracks. Okay, you added a new fallible function that can error out in this way, and it just tacks them all together. And then at the end, you can look and see, these are the 6 possible errors.
And more importantly, the compiler looks at it and goes, there's a new error in your system. So everybody who's calling this code now needs to deal with it. Doesn't rely on somebody, you should go look at the docs and make sure, if they're even in there, and make sure that you cover this new thing that's happened, that's just slipped through. And if you just upgrade your code with thinking, this is going to be better, you may have a new error that you don't know about and your code's broken now.
Yeah. Yeah, so huge way forward with effects and error handling. So that's one of our chapters that we go into detail on.
Yeah. Well, I think, the functional community has had a really hard time getting these ideas across. And I think sometimes they get a little frustrated because everybody else isn't as smart as they are. And so they can even come across as a little unfriendly.
That was one of the really great experiences about working at Zyverge as they were getting the Zio 2.0 release ready to release. And so Zio 1 had a lot of innovative features for Scala, but it was very clearly inspired by Haskell. And a lot of the naming and concepts betrayed that. And Zio 2, yes, there were many new features added and all sorts of improvements, but I think the thing that stuck with me the most was how much time they spent on the naming of all these things and just really having so many long debates about, okay, this thing has an established category theory term, and we're going to get a lot of heat if we don't just stick to that term.
Heat from who, though? Heat from the in-group.
Yes, heat from the people who already understand that stuff. And so he just went top to bottom through the entire project and said, what is the most easily understood and discoverable name for all the capabilities in this library?
Guessability.
Yeah, that's a huge part.
They've optimized this for the dot completion in the IDE.
Exactly.
So you've got an effect, you hit dot, and you get a whole bunch of options. And a lot of times you just guess the name of what you're trying to do, retry oh, it's called retry, and you find it there in the list, and yeah, it just has made it so much easier to guess your way to the operations that you want to perform on the effects.
Yeah, and the naming there's retry and there's retry N, and so they make sure that the variations
At the end.
are at the end, so that as long as you get that base, you tab complete up to a point, and now you see, okay, there are 4 variations of this one bit of functionality. Which one is appropriate for me? And so they really optimize for, even though it's a little bit clunkier to verbalize sometimes, because we tend to put the adjectives in front. When you're writing code, it is a much smoother experience. And yes, you still have to consult the docs at various points, but it's far less than some of the other functional programming approaches.
Well, because some of those came from, or maybe a lot of them came from the time before everyone used IDEs. And to acknowledge that, oh yeah, we all use these things now, and so that should be a part of the design of your library, is really an important step forward, I think.
Yeah. We should point out that the book is not intended for people who already are Haskell functional programming experts. There's a lot of people out there that already kind of know what effects are, and maybe want to know like how Zio works. We're not trying to be that book. We're not trying to be the book for hardcore functional programmers, or the dive under the covers.
It might make them mad.
Yeah.
Because we have worked so hard to make it simple and clear, and to hide the underlying machinery.
Yeah.
And if you're someone who says, no, you have to understand the underlying machinery, which would, I feel like, be the same as saying, well, you can't write a program until you understand how the compiler works.
I think our audience is people that want to use effect systems. It's not people that are going to build their own effect system. We are not describing all the theoretical underpinnings and how Zio's runtime works under the covers to be performant and give you all these guarantees.
Which I'm still curious.
Yeah, and
But realizing, for a long time I thought, oh, I'm going to have to understand all this, because you guys were talking about that and how it works, and I'm going, all right, I guess I have to understand it. But then we got to this point where I go, oh, I can see what it's doing, like I'm programming with a language that I don't understand the underlying workings of. And it's, oh, okay. And I think it's not just people who want to use effect systems, but more importantly, people who want to know, why would I want to use an effect system?
Yeah. So I think hopefully this is a book that is helpful for that audience of people. It's not intended to be for everyone. One of the things I want to talk about was how we made some, to kind of serve that goal, we put in some infrastructure when we were writing the book. We spent a lot of time on book infrastructure. Kind of surprising how complex our build system, CI system.
There's so much stuff.
Yeah. Which is fascinating. You read the book, you would have no idea just how much work it is to get the examples, to build and be correct and get the output correctly there, and tests. So we have a lot of tests for our infrastructure for our book. Tell us about the forbidden words, Bill.
Yeah, so the forbidden words, that is our way of keeping ourselves in check and not succumbing to the temptation of getting into some of those underpinnings and just all the things that we propose you do not need. And I won't read the entire list here, but these are words that we can guarantee you will not see in the pages.
So we actually have an integration test that we run when we build the book, and the build will fail if there is any of these words in the book.
Yes. So I think the big obvious one up front, the elephant in the room, is monad.
We can describe effects without monad,
Yes.
even though it is a monad, but we did not need it.
Yes. And I don't recall how much time we spent implementing monads, probably 2 years ago at this point. We just built up monads over and over and over again, trying to
Reinvented, basically.
Yes, it was. Well, we already have Zio, and that's the one we're going to talk about. That's going to be the real one. But we want to implement a toy version, and we want to show people how to make a monad. And we did that at least a half dozen times over the course of probably a couple months, all told, before ultimately just deciding no. And that'll be a contentious one with a lot of people, I'm sure.
Well, and I think it's worth going a little bit further on this. Monads are there,
Yes.
but we were able to describe effects and have code that uses effects. And we think that we accomplished the goal of not needing to even say that these are monads in the book. And, we'll love to hear feedback on that. But we really, I think, achieved this goal of like we don't have to get into the functional programming terminology that can scare people away. And maybe at some point people discover, oh, these effects, they're monads, and that's cool because they have these properties. And, but it was unnecessary for what we were trying to achieve.
And certainly not at an introductory level. I mean, that kept blocking me because there was all this math and stuff around the monads. I'm going, all right, I guess I have to understand this. But now I realize, no, I didn't. I guess the question somehow came up was, do we have to do this? And somehow the answer was no.
So flat map is also on the forbidden word list because that's the function used with monads. And we do not need to have a flat map in the book. And somebody had asked me on Twitter when I shared the forbidden words list how we got away with not using flat map. And thankfully in Zio, there's something called Zio Direct, which allows us to write the essentially monadic code without the flat maps and maps. And so
which was brilliant.
Yeah, so that was which I think makes it much more approachable. It's it's certainly the flat maps are still there. They're just like abstracted away, and so our readers don't need to think about flat maps.
It's just like we're running this code, and yes, we are moving things around in CPU registers, but
it's on the Java virtual
we're not going to
machine,
show that.
But we don't have to explain the Java virtual machine.
Yeah. So thank you to Alexander Yoff for creating Zio Direct. It is just so fundamental to the style of our book, and let us just sidestep so many of these off-putting concepts.
Yeah, there was like a week or two where we were going, what? We can, what? It's just like, look, it all falls away. Can we use this everywhere? Yeah. Yes, we can. Okay, let's use this everywhere.
And so historically, flat map is how you deal with effects and monads and all that. And Scala took it a step forward by giving for comprehensions so that you, in most situations, don't need to actually invoke flat map. You can just use the for comprehension. And when we finally got to the point of, wait a minute, we don't need a single for comprehension in this book. And it's just one more step along that path to making the code more approachable.
And I gotta say, the only reason that I actually finally understood for comprehensions is because we had it in this much simpler form, and I go, now I see what the for comprehension is doing. All right. Okay. It is awkward. It's definitely so much more awkward than this. And that's why it was confusing to me.
Yeah. What else is on the forbidden word list?
Yeah. So kind of paired with flat map, a big one was map, which I think is one of the simpler functional programming concepts and was not even on our radar as something to avoid or eliminate. But as we whittled this down, there came a point where we realized, oh, there's only like 2 or 3 places where we're even using map here. And then we could take a closer look at those and realize, no, we don't even need that. Like, we can just use Zio's for each operator. And yeah, that does just, it reads a little simpler. And I think people know if you say for each and then pass it a collection, there's a pretty strong chance that the new reader
is not going to get stuck
what's going to happen there. Yeah.
There you go. Okay. Yeah.
So there was places where we would look at the examples that we had and we'd be like, there may be a way to make this more approachable. And I think we did a number of those iterations where it's like we had the sense of removing this, reframing it into a different way will just help us achieve our goals of making this even more approachable and accessible to more developers.
I wish I could remember the specific one. I know there was one that caught your attention and you tried to rewrite it
like
so many times. You know, we would end our group work time. You'd go off and spend an entire late night just trying to figure out how to get rid of this thing. And I kept saying, like, just forget it. It's not worth it. Just tolerate that bit of awkwardness. And you just kept returning to it and kept returning to it. And months later, we finally realized, oh, we can't change just that one line that's really pissing you off.
To reframe the whole concept.
We could reframe the whole thing, and then it just evaporated.
Yeah.
And that unease you felt and wouldn't give up on finally paid off.
Yeah.
And it was one of the crucial steps to just eliminating another term. And
we probably have a forbidden word from that experience.
Yes, like, I can't.
Yeah, what forbidden word spawned out of that? But that was often what happened is when we discover those frictiony, you know, the parts that were rough, that we thought were rough for readers. It would often result in adding a new forbidden word into the list. So
I had that experience. I was looking at some code while I was doing one of the many, many, many edit passes, and I go, it seems like this could be better. And so I asked the AI to rewrite it, and it did. And I go, oh, that's why we didn't do it that way, because it introduced one of those words. Okay.
Yeah, so there was the occasional compromise where maybe using this term would have made the example a little simpler, but I think by and large it went the other way of we ended up boiling down our example and just making it simpler because we didn't have the temptation of using any of these more advanced things, such as fold, which is another one. And I remember,
I love fold, but
I do too.
It's just not appropriate for this book.
I remember, I don't know the name of the blog post, but it was just kind of a celebration of fold in the world of functional programming. And I love the article. I still do. And just showing, like, fold is such a powerful, fundamental operation, and you can just turn any data structure into any other data structure if you describe a few basic operations.
It's like a basic atom of programming, but just at this higher level.
And you can derive so many other things.
I mean, really, traverse is the. But we don't get to that. But yeah, so fold made the forbidden word list,
and we
just didn't need it. You know, there's better ways to explain things.
And a couple other, the phrase category theory. We didn't want to talk about that, and then
there are other books for that. There's actually some really fantastic category theory.
When you understand why you would want to learn that stuff.
Yeah, so in the realm of category theory, there's applicative, monoid, type class, functor. These are all incredible innovations, discoveries in the world of software
that
engineering.
enable this,
They-
but that you don't need to understand in order to use it.
Yes. So I have nothing but good things to say about those types and those concepts. And I'm glad at all the people that toiled away and figured out how valuable they were to facilitate software that we can trust and really count on to run properly. But we have shielded the hypothetical reader from any of that stuff.
I gotta say, I'm amazed. I mean, seriously, after all the stuff we waded through, I never thought it could be reduced to this level of simplicity and clarity.
Yeah.
So,
And so concisely. I mean, it's like 140 pages or whatever. It's a pretty short read. And we think that's a good thing because hopefully we have put so much work into making it this concise that creates a lot of value for the readers. I was wondering if you had to guess how much more code we actually wrote versus how much code is in the book. Like 10x? Like,
oh, you think it's that much?
Likely more, like
Yeah.
30x. Like we've written so much code to get to the place that we got to with the code that's actually in the book.
Yeah, and to again talk about things that I appreciate but don't want to replicate with our book, the Red Book is
Spell the
a
Red Book. Yeah.
famous or infamous book, depending on your perspective, which is it's an incredible accomplishment, and the way it lets you build up all these concepts.
The title is Functional Programming in Scala,
Yes.
By Grunar and Paul.
and
Yes.
it's Manning
Yes.
Press.
Yeah.
Okay.
Fantastic book.
By fantastic
dense.
authors.
Yeah.
Again, all great. But I know so many people, in addition to myself,
And
who
me.
just crashed on the rocks of trying to get cover to cover in that book. And I don't know how many attempts it took me to get through all of it. And I actually don't even know if I finished the last couple of chapters because it's so dense and it's so precise. It is very impressive, but I would love to know the stats on how many people started it versus completed it.
I got all the way through, but I feel like I understood maybe half of the easier stuff.
Yeah.
But yeah,
So we wanted to have a book that people could get all the way through and hopefully understand everything. And it took a lot of exploration over years to be able to get to the conciseness that we arrived at.
yeah, I'm pretty pleased with it.
Any last words? And do we want to share the podcast?
I think we should.
The
AI podcast, I
yeah.
absolutely think we should.
So-
just as a
Just
mind
Don,
blowing,
We'll put that at the end of the
just as a
episode.
mind blower, just
Yeah.
like all synthesized. Because we were traveling someplace, and you decided to feed the whole book into
I put
this
the book
thing.
into Google's Notebook LM.
Yeah,
And
it said
in like
make a
3
podcast.
minutes, it created this podcast.
Which is like and they came up with new analogies that we never thought of. I'm not sure if they're great analogies, but still different. I don't know. We were all just blown
might be
away.
helpful.
Yeah.
And maybe the feedback we get is that we can just replace us with AI in the future.
Well,
So,
we're lazy about
Yeah.
the podcast, so that
it does make a few mistakes on pronunciation.
yes, it does.
Layers.
Yeah,
Um,
but I mean, my theory is that that's to keep us from panicking about. It's all part of the grand scheme of the AI, the minds, to keep us from freaking out. They're going, oh yeah, it's still
Make a
clunky.
few intentional mistakes. so that-
Exactly. Keep the humans from getting overexcited. Yeah.
Anything else?
Effectorientedprogramming.com. You go there. All the links are
Yes.
there. You can buy the print book. You can buy the ebook. We also have how to set up. Hopefully the instructions are careful and clear how to set up and run the examples on your computer, which you can try even without the book. So it's all there.
Yeah, so if you prefer the paper version, you can get that, but I would say this is a book where that was kind of the afterthought.
Oh, yeah.
We want this to be read on your phone and to just for you to be surprised that you never had to switch devices. You never had to jump over to a widescreen monitor.
Right. But it'll also work on your, you can load it onto your Kindle or your iPad, and those are really good experiences. And then there's a PDF version, so if you just want to read it on your screen, that's probably the nicest version, or even print out some of the pages from there. So it's available in all these formats. But the book itself is nice. The people seem to really like the cover. We had our designer create it for us, and it was part of it was inspired because 2001 is Bill's favorite movie, and there's a certain analogy to the monolith, and we'll let you figure that out.
Fun. All right. Well, yay, we did it.
Yay.
And hopefully,
Yay us.
Yay us. Hopefully, people get something out of it.
Yeah.
All right. Thanks.
Ever feel like your code's about to go up in smoke with one wrong keystroke? Like you're constantly playing whack-a-mole with unpredictable problems.
Oh, tell me about it. Database is acting up, APIs timing out. It's like trying to herd cats.
Right? But what if there was a way to make those unpredictable parts?
Yeah.
Well, predictable. That's where effect-oriented programming comes in.
That's the idea, anyway.
We're diving into effect-oriented programming, a new paradigm for creating reliable, adaptable, testable systems to see if it lives up to the hype. This book is all about creating systems that can handle whatever you throw at them.
Yeah, and a big part of that is how they deal with these so-called effects. Basically, any part of your code that interacts with the outside world. Those are where things get unpredictable.
So anything that's not just like pure calculation within my code.
Exactly. Think about saving data to a database. That's an effect. You're sending data out into the wild, hoping for the best, but anything could go wrong.
Ugh, don't remind me. Just last week, I had some code go haywire because I totally blanked on time zones. Didn't even consider it.
Happens to the best of us, believe me. And that's often how technical debt creeps in. Those quick fixes and workarounds that seem fine in the moment.
But come back to haunt you later, like patching a leaky pipe with duct tape.
Perfect analogy. You might hold things together for a bit, but eventually.
You're calling in a very expensive plumber. So, is this effect-oriented programming, these effects they talk about, is this the solution, the non-duct tape approach to coding?
It can be a powerful tool, for sure. Instead of just crossing your fingers and hoping for the best, it makes you think about those what-if scenarios up front.
So you're designing for resilience from day one. I like the sound of that. How does this all work in practice, though?
Well, it's not tied to one specific language or anything. It's more like a mindset shift. This book focuses on a system called ZIO, which is just one way to do it, but the principles apply more broadly.
Okay, so ZIO it is. For today, at least. Let's dig in and see how it actually helps us wrangle those unruly effects and build something that lasts. All right, so ZIO helps us write more resilient code. I get that. But how does that actually work when I'm knee-deep in code?
Okay, let's go back to that time zone issue you mentioned. Say you're building something that needs to send notifications to users in different time zones.
Oh, been there, messed that up.
Right. So with ZIO, instead of just assuming the time zone conversions will work, you can actually treat that time zone lookup as effect. Like, hey, this could go sideways.
Okay, yeah. But how does that actually help me avoid making the same mistake?
So that's where those ZIO superpowers come into play. It gives you these tools for handling potential problems. One of them is called retrying.
Retry like try again a certain number of times.
Exactly. It's like a safety net. You can tell ZIO, if this thing fails, try again up to, say, 3 times before you give up.
And if it still fails after all those retries, then what?
Then you've got options. You could log the error, show the user a friendly message, or try a different approach altogether. You're not just left high and dry.
So instead of my code being this fragile house of cards,
Or like a,
bouncy castle.
I was going to say a sturdy oak, but I like the bouncy castle.
Right. You can handle a few bumps and still be fine.
Yeah.
So what else we got besides this retry thing?
There's or else fail, for one.
Or else fail. Okay. What's that one do?
So say your time zone lookup just totally tanks. With or else fail, you can tell your code, all right, if that fails, do this other thing instead. Like use a default time zone, or tell the user there might be a slight delay.
That is incredibly useful. I can think of a million situations where you need a plan B for when things go wrong.
Exactly. And these tools aren't just for handling errors either. You can use them to model all sorts of complex logic, interactions with the external systems, anything that might be unpredictable.
Okay, I'm getting sold on these ZIO superpowers, I have to say. But I got to be honest, sometimes just managing all the different parts of my code, all those dependencies, it feels like a full-time job in itself.
Yeah, dependency management can be a real headache. But just like with effects, ZIO has a pretty elegant way to handle that too.
So we've got these awesome tools to deal with effects, those unpredictable things our code has to do. But what about managing all the moving parts inside our code, all those dependencies?
You mean like databases, APIs, all those things our code needs to actually work?
Exactly. It can feel like a juggling act sometimes, especially as your project grows.
Totally. But just like with those effects, ZIO's got our back. It's got this thing called layers.
Z layers. Okay, I'm listening. How do they help wrangle dependencies?
Think of a Z layer like a recipe for your dependencies. It's not just a shopping list of ingredients, but actual instructions for how to put them together.
So instead of saying, I need flour, it's like, here's how to get the flour, and oh, maybe sift it first while you're at it.
Exactly. It's about making those dependencies really clear and, well, reproducible. So let's say you need to talk to a database. With layers, you'd create a layer specifically for that database connection.
And this layer would handle all the messy details, like actually connecting, handling any errors, closing the connection properly, all that.
All of it. It's all neatly packaged in one place, makes your code way cleaner and easier to understand. And here's the cool part. Is layers work great together. You can compose them.
Compose. Like music. Are we writing symphonies of dependencies now?
Huh. Not quite symphonies, but you get the idea. If one layer needs something from another layer, say your database layer needs some config settings, you just stack them together. Each layer adds its own piece.
Okay, so it's less like a tangled mess of dependencies and more like...
More like.
I was going to say a well-organized bento box, everything in its place.
Perfect. And you know what else? This whole Zealer thing, it makes testing a lot smoother too.
Oh, really? Because testing with dependencies can be a real pain.
Right. You're always having to create these fake versions of your dependencies, mocking things out. It's a lot of extra work, and it can be error-prone.
Tell me about it. And then there are those weird edge cases that only seem to pop up in production.
Well, with layers, you can swap out those real dependencies for test versions in a controlled way. Want to see how your code handles a database error? Just create a special test layer that simulates that error. Boom, done.
Okay, now you're just making me excited. So no more late night debugging marathons.
Yeah.
Trying to figure out why my code hates me.
No, I can't promise that.
Yeah.
But it definitely gives you more control, more predictability. And that means more reliable, testable code, which is always a good thing, right?
Music to my ears. So to wrap things up, it sounds like effect-oriented programming, especially with a tool like ZIO, can really help us wrangle those unpredictable parts of coding. From handling those external gremlins with effects to keeping our dependencies in line with Z layers.
It's a whole new way of thinking about software development. We're not just hoping for the best anymore, we're designing for resilience from the ground up.
Love it. All right, folks, if you're ready to ditch the duct tape and build some rock-solid code, check out the show notes. We've got links to more resources on effect-oriented programming and ZIO. Happy coding.